In this lecture, we are going to study test of association for two categorical variable in SPSS. So our scenario is with the cross tabulation, like we have two variable and both are categorical in nature. So the scenario is like that. If we have two category variable, two variable, the scenario can be classified into two. That is, either both variable had two categories, and either any one of the variable had more than two category, or both have, or at least one of the variable had more than two category. If both variable had two category, for example, smoking and the lung cancer. Smoking, yes, no, is a category. Smoking status. Another variable is lung cancer, either positive or negative. In this case, so we will check if the certain assumption of chi-square fulfill or not. This x square is nothing but the chi-square. It is a certain assumption of chi-square fulfill, we will apply the chi-square. Otherwise, we will apply the Fisher Z test. But if we have more than two category in at least one of the variable, we will check if the variable assumption fulfill. Then we will apply the chi-square. Otherwise, we will use any other remedial measure, or we will seek any other kind of statistics. Our concern is more toward the chi-square test, which has an hypothesis that the outcome variable or response variable or dependent variable does not depend on the treatment exposure. An outcome variable or response variable depends on the treatment or exposure. For example, the smoking status is here, which is an exposure, and the disease status is here. So we can say, like for example, the 13 people were those who smoke and had the disease, and 144 were those who did not smoke and did not have speak out of 200 patients. So this is the formula for the chi-square. Although we are not using this in the SPS directly apply this, but assumption which we were talking in our previous slide is that first assumption is that each observation is independent of all other. There is no before after effect, and this 13 and 144, 37, 6 are considered as cell counts. These are observed cell counts. We obtain by using any formula the expected cell count, and this is the requirement that not more than 20% of expected count are less than 5. That is, for example, there are four columns, four cells. So four cells, each cell comprises of 25%, 25%, 25%, 25%, 25%, which makes of 100% for these four cells. So according to this assumption, not a single cell should have less than five expected count. So this is computed by the SPSS again, and it also tell in the output that whether your table had how much percent of the expected count are less than 5. So if the second assumption does not fulfill about this one, so if we have two category in both variable, we will see the Fisher reset test which is obtained in the output of the chi-square. So we are working with the lecture data, which is the HSP data. It has 10 variable, 5 variable are categorical and 5 variable are continuous. And we have the female as two category as male and female, race with four categories as Hispanic, Asian, African American, and white. And we have the ordinal socioeconomic status with three categories, as school type with two category, type of program with the three categories. In our scenario, we are going to work out the association between the gender and type of school, and also check the significance of the same association. For that, we will proceed to the SPSS. Like we have to seek the analysis with the gender variable and with the type of school. So we both are categorical variable, and coincidentally both are nominal variable. So we will go to the analyze and then descriptive statistics and then cross tabulation. In the cross tabulation, the SPSS asks to put each variable in either row and the column. So we are going to put the female in the row column and the type of school in the column. although it does not affect the analysis of chi-square, the p-value, but still there are some assumptions that the dependent variable should be in the column and the factor variable in the row. Well, then there are different options. We will seek to the statistic which will yield the chi-square, and there is one false option is the chi-square. We'll press continue, and they will and then we will there are other options we can also sign in tau. So we'll press OK. In the OK, when we press OK, it will produce three tables. One is about the case summary, that how many data variable data observation we have. Second variable is second table is about the cross tabulation, which is employing, which is actually depicting the number of the cell count. Like we, for example, there are 77 males in the public school, 14 males in the private school, 21 female in the public school, and the 18 female in the private school. A total of 2200 student data we have. To check whether that male and female are associated with the type of school, we will seek this table, which says the chi-square test. And the p-value of the chi-square test is here, which is 0.828. But before proceeding toward the chi-square test, first we have to check the assumption of the 20% count. Luckily, we have the 0% count, which have expected count less than 5. Means none of the cells have expected count less than 5. But if instead of 0% there was written 20%, so we cannot apply it. We can the chi-square test is not valid. We will seek the Fisher result test. So this time we are lucky to have that our assumption fulfilled, and we will check the p-value of the chi-square directly, which is 0.828. So this implies that the type of school and the variable gender the null hypothesis was rejected, and we will say that the type of school and the gender have no significant association.